Hello, everyone. Welcome to the new year and the first 2022 episode of the Day Zero podcast. As always, I'm Spectre. With me is Z. Where we were off for a few weeks, some of the topics we have for today are ones that happened over the winter break. So you might have seen them if you were, keeping up with the feeds and stuff towards the end of 2021. And that includes our first vulnerability, which is in RocketChat. So let's get into that. First thing I'll say before we cover this issue, even though this was disclosed publicly on December 21st, as far as we know, this is an issue that still affects RocketChat clients on the latest version. The vulnerability was reported back in September, with RocketChat being quick initially to respond and patch the issue with a fix shipping in October 2021. But then SSD or the researcher found a bypass because it seemed the fix was somewhat flimsy. They reported the bypass and a warning that the fix was incomplete, and then they basically got radio silence. So as far as they're aware, this still works on the latest RocketChat clients. So even though this is a bit of an older report, it's still very much relevant. So getting into the bug, it's fairly easy. Basically, RocketChat allows same host navigation, meaning if a link is opened and it resides on the same host as the chat, it can be opened in the desktop app itself. So if you can somehow get content on that host and produce a link to it, you could get an XSS on a client if they click that link. Well, the way you could do that is via file uploads, which are a feature that is supported by RocketChat as well. And file uploads work by proxying to the backend storage, like S3 or whatever, with a link on that host.
So
The
they
other
won't.
part of the problem is that node integration is enabled on workers, so that XSS then becomes an RCE. Go ahead, Z.
Yeah, so they won't quite proxy it. They'll redirect you. So it'll create a URL that redirects you to S3, like a signed S3 URL. So not quite proxying, but close enough for this purpose. Because it doesn't care about whether or not the actual website it's showing is same host. Because what's going on in the actual code, which I've just pulled up, is when it's creating the links on your message body, this their uh the link code. Basically it's seeing the link. Does the base URL start, or does the URL start with the rocket chat base URL for whatever rocket chat you're on? If it does, or if it doesn't, it uses the blank target, otherwise it doesn't. So it'll basically be any link can be used there. Thank you Imperial G for the 5 months now of Prime Sub. um Coming back on to this, because of that, like, that's just kind of an interesting attack vector when it comes to these Electron applications in general. They didn't need to use it here, but I kind of want to shout out, like, the whole same host navigation, or just the navigating of the main window itself, the main application window, because it's just a browser window. Those links, if you don't add a target, are going to basically hijack the entire UI. And that kind of matters a lot on Electron applications, because you don't have a URL bar to look at and see, like, hey, am I actually on the right page? So, imagine on Discord if you were able to redirect the URI to something. And you click the link and suddenly you have like a Discord login prompt. Could be phishing, maybe it's legitimate, but you have no way to tell on most Electron applications. In this case, obviously, they just use that because you get JavaScript running. Node integration, as Spectre said, was enabled. Therefore, you can basically just execute whatever code you want. But I did want to shout out kind of that other attack vector, which is if node integration's off, still being able to control the entire UI can be reasonably impactful on like an actual targeted attack. Bounty payout would not be anywhere near as much, but it's still, something.
Yeah, what you were saying with Electron apps and lack of a URL bar kind of reminded me of when in Google Chrome they tried to change the URL bar to only include like the host name, like it wouldn't include any of the path information, and that had a lot of people in an uproar for the exact same reason. Maybe it looks a bit cleaner on the UI, or even cleaner not having a URL bar, but it's not as great from a security standpoint because you don't have the confidence that what you're seeing is actually legitimate and what you're expecting to see. So, yeah, I mean, it's a fair thing to call out for sure. Something I wanted to highlight though from the POC video, towards the bottom they have like a demo video This isn't quite a zero click. So when you click on the link, it will bring up a prompt like, do you want to open this in like the RocketChat desktop application or whatever? Because that is kind of a useful thing that browsers do have to as like a last line of defense of like, hey, do you actually want to open this in an application or whatever? So it's not a zero click, but I'm not trying to say that that neuters its impact too significantly, because I feel like a lot of the time when people see these prop ups, they probably go for, okay or whatever, just
I'm
out of
not sure
habit. But
about that one in particular, actually. I didn't take a look at the proof of concept video, so I did not take notes of that. But that actually, in my mind, does diminish it a reasonable bit. Um,
yeah,
actually,
I
so
don't know. I could kind of see it, but at the same time, how much stock do people actually put in those like pop ups? You know what I
I
mean?
can
I
definitely
don't
see
know.
people like clicking over a warning or whatever. But like there's a difference between that and just like you click a link and I have to log into Discord again or something. Like okay, that actually would be kind of suspicious, but um yeah, I don't know. I mean, that I'd maybe want to go watch the video and see exactly what was coming up. But it does,
Yeah,
at least in my mind, like it has an impact for sure. Versus just not having anything. That said, I will also shout out that it feels to me like there it doesn't seem like there's a good reason not to just have target blank in, because this code is the message body. So presumably this is your chat messages in the body. I don't see a reason why any link in a message body should need to be opened inside the application itself. Like, I mean, I can, in some cases, because it's a web app and all of that, like, you've got links that do need to be open in the app. Like, you're going to change to a settings page or something, so it opens in, like, a new page in the app. Fine, like, that makes sense, but this one is specifically message body content. I'm curious what the use case is. Maybe they're reusing this somewhere else that isn't a message body, and that way they can just use like the markdown processing or whatever, and it's all the same. Maybe it's something like that. It just seems, I don't know. I don't see the use case. I'm sure there's something, like there is a reason this exists. I just don't see it, and I don't use RocketChat, so maybe it would be more obvious if I did.
yeah. The thing that is a little bit unfortunate to me is I wish we could see what exactly the initial fix was. I don't know if you would have caught this where you went into the source code a little bit. I didn't really uh, look into that, but like I said, like towards the beginning of the topic, like they did try to initially fix this issue according to SSD disclosure, and it was like a flimsy fix. So I don't know if the part they must have tried to address was that target blank code, because like it would be kind of impossible to screw up fixing node integration being enabled on workers. That's just something where you flip a switch and flip it back off. So yeah,
Well,
I'm
they
curious
probably
what.
need node integration. Just in terms of something RocketChat's doing, like node integration can be a necessary thing.
It could be a necessary evil. Yeah. Um,
Well,
yeah,
I
I
mean,
just
node
mentioned that because
integrations.
SSD disclosure mentions towards the remediation steps that it should be disabled. But that said, they might not know if it's needed or not either.
Yeah, and I'm trying to look here. I mean, I guess I'm probably just in the wrong branch for the link here because I only basically see a version bump and the commit for a new parser.
Yeah, I tried
Um,
looking at the commits for that file too and didn't really see anything useful. Um, so hard to say exactly like what they tried to address there.
and
But
we've got a bit of time between like disclosure and when this was reported and possibly patched. So yeah, I'm not sure.
yeah, bit of a weird situation all around. Um, but yeah, I did want to point out that thing with the alert, because I some of the people I saw talking about this were talking about it as if it were like a zero click, and that's not completely the case. So
Well, I mean, even because it is a link that you have to click, like it can never be zero click.
sorry, yeah,
But
okay,
yeah,
maybe
I
I
know
should
what
have
you mean.
been more
Yeah.
clear. Yeah, like click and you're dead. It's not quite that. You do have to make an additional click after that to confirm your demise, I guess. So impact is a little bit impacted there. But yeah, so up next we have a post from Lauritz Haltzman disclosing a login flaw in Flickr that allowed account takeover with an auth flow bug due to configuration issues when using AWS Cognito, which is like a managed authentication provider by Amazon for dealing with OpenID Connect and SAML and whatnot. Before getting into the root of the bug, some information on the authentication flow is needed since it is kind of like a logic somewhat involved logic issue. So basically, how Flickr's auth works is some JavaScript is ran by the end user from the identity endpoint of Flickr, which will send credentials to the Cognito server, which will then respond with various tokens, including the access token, which then gets forwarded to Flickr and used for authenticated actions. A somewhat standard flow going on there. What's worth noting here is since these are normal Cognito tokens, these tokens can be used outside of Flickr's normal auth flow to make direct requests to Cognito through AWS's API, through the command line interface, if that token isn't protected against direct API use, which, spoiler, it isn't in this case. And I bring that up because it will kind of be relevant for the bug when talking about it in a little bit.
Well, so you can't really... so the issue here is the fact that that token has read and write permissions. You can't really just say, like, oh, this token can't be used for the API. Because the whole point is that it's token for the API.
Yeah, so that was the next thing I was going to get into.
Yeah. Sorry.
Yeah, no worries. So, yeah, as always with token-based auth, the permissions that are assigned to those tokens can be very important. So that was one of the first things they looked at. And as he just mentioned, the token gave the user read and write access to user attributes or claims that are attached to the account. When they looked at these claims, they noticed something very interesting. Among the various attributes that were used were ones for the email and email verified fields, which were used to link the account to the account holder's email. And verified is said if the user verified their email with a code that gets sent there. Well, using this access token in the API, you can write to that email claim, which on its own is maybe perhaps reasonable. Maybe someone would want to change the email in their account or whatever. But there's a few problems here. For one thing, that email claim is case sensitive and is entirely user controlled and not trusted. For another, Flickr doesn't actually check the email verified claim when performing update actions, like updating an account's password. And that's problematic because you can perform sensitive actions using an email that you don't prove ownership of. Now, in Flickr's normal authentication flow, it normalizes the email addresses and only sends lowercase emails to the back end. So you wouldn't just, like in the web panel or whatever, be able to change your email to collide with another user's email and then update account settings. But as I mentioned earlier, you don't have to go through Flickr's normal authentication flow. You can use AWS command line to access the backend directly, which won't be subject to that normalization process. So you can cause a collision with an already registered email address by updating an attacker account with a victim's email with the case changed because it's case sensitive. And because it's case sensitive, Flickr believes the email to be unique. And because they don't bother checking the email verified attribute, the attacker doesn't need access to that email address to change the account settings. So yeah, it seems to be kind of multiple failures here. The main one being, like what Z said, is the fact that the right permission is attached to that token. But yeah, go ahead, Z.
Yeah, so I actually think the root issue here is separate from there. Okay. I mean, the fact that the user can edit it is a problem, and the read write. But the root issue in my mind is actually the fact that there's only one user attribute from Cognito that is guaranteed to be unique per user. So the general idea with these flows is, Flickr, they manage their own kind of accounts. A lot of their account information is going to be managed on like their end. They're going to have their own internal database. And what they're going to do is they're going to take these Cognito accounts, they're going to map, in this case, they're mapping that email, and they're going, here's the email from Cognito. Now, which account does that reflect on our service? And then because of the normalization stuff, you get around the fact that emails need to be unique. But it basically ends up looking up, just based on that email, it ends up looking up, somebody else's account. Besides that, there's only one user attribute that they should be using for this lookup, and that is the sub or subject field. That's the only one that's actually guaranteed to be unique. So if when they got this response from Cognito, they just looked up the value for that sub, got that unique value, that guaranteed unique value, and then looked up the account that was associated with that, there wouldn't be an issue. It's the fact that they're using that email field instead, which can be messed with, which can be changed. That's where you're kind of having the rest of these issues pop up. So I think the more fundamental thing is not using the subject field and using something that isn't guaranteed to be unique or any, like, has no guarantees really. Um, Fundamentally, I think that's where the issue is, rather than these other things. These other things make it exploitable, but the core issue to me is they're just using the wrong attribute. They should be using a unique value for each user to identify them.
That's fair. And if you go to like the hints for developers section that they have at the end for like how this issue could have been prevented, number one is exactly what you said. Don't rely on the other claims. But number two is kind of what I was getting at the beginning when we were talking about the tokens, and you were saying that that's the point of the API. So yeah, what they're saying in point number two is if you use Cognito, evaluate if there's a need for users to directly like mess with their user attributes in the API. So it seems like you can protect these tokens from being used in the console and outside of your normal authentication flow. And that's kind of like where this bug comes into play too. Like you were saying, if they relied on the subject claim, then this wouldn't have been a problem. But on top of that, the fact that you can mess with those attributes from and bypass the normal normalization path, that kind of causes a desync, and that's just going to cause problems with any assumptions that are made later on down the line. It's
Yeah,
we
like
talk about
it's
desync attacks a lot, and that's a reason is that it's so easy to break a whole chain of assumptions if you allow other paths uh, to the same code.
yeah, like I mean, I'm definitely not saying that it's a non-issue. Just more fun. The most fundamental one, like the root cause in my mind, is the subject claim. But
Yeah. This is a bit of a fun bug because the few times we've talked about like authentication flow bugs before, I say the few as if there's only like one or two of them. We've talked about them a lot, but um, one of the points that's always been hit home by the blog posts that cover it, and I think you've hammered this home too, Z, is like using a dedicated provider for doing authentication is always like the best move. Like a lot of the problems we saw were in custom rolled authentication, and in this case, they did use like a properly established authentication mechanism, being AWS Cognito. But it just kind of shows that even if you do use one that's already established, it doesn't mean like you're going to be safe for free. It's not necessarily going to be easy to configure or have it work properly, and this is just a problem with like token based authentication in general. Setting these fine grained permissions on them properly and knowing what to trust and what not to trust is something that's always been a haunting problem. And in this case, Laurie Holzman actually calls out Cognito a little bit for their shaky documentation, saying that some of these issues they couldn't really blame the developers for because the documentation was just not well written, or it didn't really make some of these pitfalls well known. So yeah, it's just kind of showing that like even if you use an established host, you still need to there still needs to be an audit. It's not going to be easy if even if you don't roll your own solution.
I mean, you can use any solution incorrectly. Um, and I do want to jump back slightly, just indicate like it's not that like you should always just use an authentication provider. Like that isn't really my position. I do think there are some strong considerations for doing so. Just in terms of kind of centralized, in terms of like that's their job is to get this right. Um, I haven't used Cognito. Actually, I haven't used any of um
The OpenID
like
Connect.
no, I've used OpenID Connect stuff. But the cloud provider versions. Like I'm thinking of things like integration with Authy with 2FA or what's there's another company. It's slipping my mind as things usually do during the podcast, but I was thinking more of those companies than necessarily these, but Oh, because I mean, one of the issues with Cloud and Auth has a weird history. Like, there's so many ways, like, AWS IAM, like, there's just so many things that can go wrong with authentication on a whole there because they make it so fine grained and not easy to use. So that's where I kind of want to hesitate. Where he stated that my position was more of just always using like the third party provider or some other provider. Like, it does create a central point of failure, and I don't know if I'd want to log Cognito into that because it feels like there's so many things that can go wrong, in particular with Cognito and some of these cloud provided versions. I don't know. Auth is hard. I mean, you
Harder than it should be. Yeah.
there's a lot of issues that can crop up and a lot of subtle things when you go with these more complex auth flows versus just enter a password. Of course, enter a single password has its own issues, or username and password. I don't know. I like this bug though. Like, this is a great little bug.
Yeah, like I said, it's you have to understand a little bit of the auth flow and what's going on, and yeah, and this was a really well written post as well. Some of the diagrams and stuff really help to give you a really quick and good picture of what the setup looks like. So I wanted to call that out too. Yeah, that's fair
Should
enough. With
mention,
yeah.
this did get a $7,550 bounty. That was $7,500 for the actual um, issue, and then a $50 thing for having a good report.
Oh, look at that! There you go. I always like it when the vendors give a bit of a bonus for going the extra mile, doing good reports. So that's cool. Yeah, no, that's fair enough with what you were saying
Yeah,
with
there.
using an external provider. It is something we've talked about before, I know, and it has been like one of the things we suggested in some of the past authentication flow issues. Maybe I just stated it a bit too strongly that, that's always what we thought.
Yeah, no, and it's come up before. Like, I think I know the discussion you're thinking of, where I stated something along those lines about
Yeah.
using it. The other thing I will mention, there was a bit of an interesting discussion here where Flickr actually misunderstood the core issue here, because with Cognito, like, you're authenticating into Cognito into your own account. Like, you own that Cognito account. It's that mapping when Flickr maps your Cognito account back into their own database that was the problem. So there was a bit of a misunderstanding when this was getting triaged as being a thank you to Belika for 1 year now, 12 months of sub.
That might be our longest sub. That's crazy. Welcome back, Balika. Thank you.
Sorry. But there was a problem understanding that, just because you're authenticating to your own account, so they understood it as being user authenticates to their own account and they're basically attacking themselves. And there was a little bit of a back for not understanding the connection back onto the Flickr. And I remember they gave him an account and they're like, can you demonstrate this or reproduce it with this? And they're like, sure, enjoy your new profile picture. And they changed the user's profile picture. Uh, hmm, sorry. I'm not sure if the mic picked that up, but oh, and I thought it was a little bit of a fun back and forth between them as they were explaining it. It was never harsh, like, this issue doesn't matter, just trying to clarify. Like, I think Flickr handled it really well when they didn't have a clear understanding of the bug. Just a good example of how to handle that situation rather than just, like, rejecting the report outright and being kind of hostile to the reporter, asking for the clarification.
Yeah, and speaking of hostile vendors and hostile back and forth, I guess that'll bring us into our next topic here, which is turning bad SSRF to good SSRF Websphere portal. So this is a blog post from Asset Note on multiple vulnerabilities in Websphere portal, which is a commonly used enterprise solution for building and managing web portals. It's Java based and runs a bunch of servlets for performing its functionalities. So the researchers here took an available Docker image that WebSphere provides, set it up, and did some reversing of these servlets, and discovered a proxy servlet. When they looked at it, they found something that really concerned them, which was the fact that they had mappings that allowed users to reach IBM.com, www.3.ibm.com, and redbooks.ibm.com with various proxy paths. Now, the reason it's IBM specifically here is because Websphere Portal used to be owned by IBM until, I believe, 2019, if I remember correctly, when it was sold to HCL Technologies. So it seems to be maybe some legacy code that was there for something else. And this is what they coined as their bad SSRF. So they tried looking for some open redirects in some of those domains. The first two didn't really yield anything, but they focused on redbooks.ibm.com after trying to find uh, those open redirect issues. And they found it was running a service called Lotus Domino for content delivery, which I wasn't really familiar with, but apparently it's another somewhat well-known enterprise solution. And it had some login and logout flows that could be accessed on any Lotus Domino page. And of course, it supports the redirect to parameter to allow the logout or whatever to redirect to a page, which provided an open redirect issue. So by proxying from Websphere Portal to Redbooks with an open redirect URL, you could achieve what they've coined the good SSRF. They also discovered some other proxy endpoints which were vulnerable to this outside of the IBM ones. For example, there was a proxy on this PAWCM authoring UI endpoint, which I'm not totally sure what that was for, but it would allow proxying to literally any URL you wanted to by default for a bunch of different methods, like get, head, post, put, delete requests, and it also forwarded a bunch of different headers. Another one was the quicker document picker, which had some proxy routes that could be abused. The common one needed an additional open redirect, kind of like the Redbooks IBM endpoint. The internal one, though, which seemed to be accessible for some reason, was able to just proxy anywhere. Unfortunately, they didn't manage to take the server-side request forgery to do external entity injection, or XFC. They thought they might have a viable route by accessing the IBM Knowledge Center through the admin console of IBM Websphere. They found some code there that would load an RSS feed, but that functionality had been deprecated and wasn't really accessible anymore, so unfortunately they weren't really able to do much more that was useful there. Also worth pointing out, they had a bonus issue, a post-auth RCE, due to the ability to upload script applications to Websphere Portal via zip file. As you can guess, where it's a zip file, the extraction of that zip was vulnerable to directory traversal. So that's just something they kind of tacked on there. It is an authenticated bug, but yeah, worth pointing out as well.
Yeah, I mean it's authenticated, but it's something. Oh no, it's not that interesting of a bug. I did find the bad SSRF. In a lot of cases, if you were to look at this, it's SSRF, but it is limited to whatever domains. Like you might be tempted to look at that as they're doing what they can to mitigate any potential issues. Ideally, limit the actual pages that can go to, but that isn't always an option. There's plenty of reasons why you can't limit all of the possible pages that something can redirect to, or something might need access to. So going by domain is reasonably fair. So you might be tempted to look at that and just be like, okay, they're doing this correctly and move on. In a bug bounty situation, you can go ahead and look at how you can abuse the target. In a situation, if you're like consulting on an application, maybe not. Your scope might be a bit more limited in terms of what you can hit. But I mean, just kind of a reminder of those two areas that you can look for when you have a somewhat limited SRF. One being, or actually, I guess, one being just a way of escalating. Maybe if it's not in the cloud, if it's in a self-hosted environment. That being that internal admin panel. In enterprise software, it's not that unheard of. There's a lot of software where an admin panel is going to be part of the actual application and not like a separate service running. I've seen a lot of enterprise stuff that follows that format, though, just having another service running on like local host, so it can't be hit from the internet. So it's something to keep in mind when it comes to trying to escalate these sorts of issues. And of course, finding an open redirect on a limited domain is one of, the other option would be you're able to attack the secondary domain just as is, but I mean, the only thing I can really think of is using an open redirect as a way of escalating that issue, like a limited SSRF to something else. Like, I can't really think of any other issues you might be able to chain that with besides some sort of redirect. I guess it doesn't have to be open redirect, but some sort of redirect.
So I hinted earlier that the exchange between HCL Technologies and the researchers here wasn't that great. And where you can get into that in the post is towards the bottom when they talk about the timeline. So as you can see in that timeline, Asset Note disclosed these issues on September 5th, and were the issues were acknowledged, or at least the report was acknowledged September 7th. But then there were stretches of weeks with no updates. When they reached out with reminders about the fact that they were going to disclose at the 90-day deadline, they were told, yeah, we're looking into it, which then became, we couldn't reproduce the findings and you can't claim CVEs for this because we're a CNA. And then later on, they got more hostile, saying, if you do disclose these at the 90-day disclosure, we'll cite you as an irresponsible vulnerability disclosure party to the communities that we post to, which was their last response. So, kind of true to that, Asset Note obviously disclosed these issues, and they were a little bit more charitable than they had to be here, because they said they'd disclose after the 90-day deadline, which I believe was set for December 5th, but they held off until December 26th to post this issue. So they gave them an extra 20 days on top of the initial 90. And yeah, it seems there was still like no response after that last hostile one. So yet another issue in the episode where it's assumed to still be 0 day. Nevertheless, they do detail some remediation advice for anyone who might want to be secure against this problem, despite the vendor's lack of willingness to fix it. Being to modify those configuration files that they list in the post, and change the whitelist to block the various vectors that are here. They also state that you shouldn't rely on a web application firewall to save you from this, because there's just too many potential ways to reach those endpoints that WAFs aren't going to be able to cover very well. So yeah,
I mean,
bit of
in
an interesting back
general,
and forth there.
just don't rely on a web app firewall to protect you ever. Like, it is very much just a frontline band-aid sort of defense. It's like, if you need something really quick, like you're actively being attacked in some way, oftentimes automated, you can stop that sort of thing with a WAF. But if you have an actual vulnerability, the solution is not to patch it with the WAF. Like, ever.
Yeah, it's not something that should be relied upon in its entirety. But yeah, a bit of an interesting back and forth, because it seemed initially, and this was kind of true with the RocketChat issue too. It seemed initially that things were going well, like they acknowledged the report and they submitted them to the product teams, but then it just kind of fell apart the later it went on in the disclosure process. So um, yeah, a bit unfortunate with the back and forth there, but and this is software that's used quite a bit in enterprise, as they say. So um, yeah, and with that in mind, I do want to commend this post too for. I thought it explained the vectors like very well, going through, showing the exact like locations of where these were. If you were somebody that was in a position that was supposed to fix this, um, then I think this post does a pretty good job of sending you in that direction. It's very clear in what you would need to adjust and look at. So
It's a good post. They do the one thing I absolutely hate, however, and that is they have screenshots of code instead of the code.
yeah, I hate that too. That's a fair
I
call
mean,
out.
that is just, please
I think that
don't.
actually bit me on
But
this one too, because I went to copy something thinking it was something I could copy, and I was like, oh wait, this is an image. Guess I'm gonna have to type it out myself and try to, because I think I was trying to search something to um, just look something up, because I forgot. But
yeah, I mean, like,
yeah,
this is
couldn't do it.
decompiled code in fairness. Like, it's not like they can just link to the GitHub or something. But still, I mean, it's just one of those things that bugs me. But otherwise, like, yeah, great post.
Yeah, and unfortunately, that same problem exists in our next post as well, because again, I tried to search something up with it and I couldn't, and that is Polygon. So this next topic, we have a bug in Polygon detailed by Immunify, which is Polygon is like a protocol for Ethereum compatible blockchains to be built and connected together. To do that, it uses smart contracts, which are an interesting place to look for vulnerabilities, and a very profitable place because a bug in a contract like the one in this post could lead to attacks that can steal millions or billions of dollars in cryptocurrency. This one in particular was a lack of a balance and allowance check that would allow the theft of 9 billion Matic, which one Matic is about $2 billion, or $2 US. So that would be about 18 billion US dollars in total valuation, I believe, at the time. Um, as a bit of background, the contract in question here is a critical contract for Polygon's ecosystem called the MRC20 contract. And its purpose is to facilitate gasless transactions of Matic tokens, which is its main offering because it's impossible to send a transaction on the Ethereum network without paying gas because a wallet needs to sign it. So kind of how this contract works in like very simple terms is the user who owns the token will sign a bunch of information, including the operator, amount, nonce, and expiration, and that signature is then passed to the contract by that signed operator to perform the transaction on behalf of the token owner. So the operator pays for the gas and not the token owner. It kind of transfers the responsibility there. Z, I didn't know if you wanted to cover a bit of the issue because
Yeah, I
smart
mean,
contracts are like a very interesting place that I remember we were talking about recently.
this isn't really it's not a strong suit of mine, so there are definitely things that I don't totally understand on this one. But when it comes to the core issue, um, I'm not sure I actually agree with Polygon in saying that it's just a lack of a balance transfer or balance check. Uh, the route that they point out is in like the underscore transfer function, it will just transfer and transfer from. Um, no, sorry, transfer from calls transfer. It doesn't look if the from account actually has enough to cover the balance. So presumably what ends up happening, I tried actually looking for code that handled this. I couldn't really find it. That probably has more to do with my lack of understanding of this ecosystem. Um, but the fact that transfer exists, like either they're expecting everywhere to do that check. What feels like a bigger issue to me, and perhaps somebody will correct me, but is in the EC recovery function. So they have EC recover, which is basically to get like some of the signature information out of the actual hash, like out of the data being provided. And it'll respond, or the return value should be the address of like the wallet or whatever that's coming out of it. And what they do here is on certain error conditions, like if the signature length is not 65, they return the address of null or 0x0. When this v value is not 27 or 28, they return address 0. But at the very end of this, they use require. So they actually that'll actually trigger an error basically to be raised, like try catch type of error to be raised that indicates there's an error in EC recovery if the result is 0 from EC recover. So in that case, they return a proper error. In all these other cases, they're returning this address of 0, which apparently is the Genesis contract. And it seems like that is also why they're able to transfer this much Matic out of it. Oh no, maybe the 0 is completely irrelevant, but it makes sense in my mind at least that the fact that it's returning 0 here without an error condition also seems to be an issue where you're returning presumably a valid value, but not indicating that the error actually happened. Like using this sort of special value as like it's valid, but it's also an error. That seems to be an issue to me also. The patch was just getting rid of this completely, it seemed like. They got one, like the fork just is like what was it called? Like MRC no sig or something, and they just like deprecated, or at least they deprecated that function. Maybe they did go and replace it with something else. But I don't know, this like in code, like if I were treating this like a normal application, the fact that it's returning a valid address that's just a special value without any other indicator of an error, kind of it makes me it's one of those code smells that we talk about plenty.
Yeah, so the way I read this is like the issue is twofold. Um, Both the problem that they never check the value of EC recovery and the fact that transfer from won't check if the from address has enough balance to cover the transfer. Um, it is a little weird how they meld together, though. I agree. It's not totally clear on that part of it. Um, and yeah, like this is a very serious issue. Also very weird because I don't know how this code could have been written or audited at all and be assumed to be correct. These seem like fairly obvious bugs as far as smart contract bugs go, at least. And that's probably why this bug was discovered by a few others. While this researcher, Leon Spacewalker, had discovered this bug, another independent researcher had found it as well, who was also paid out by Polygon as a one-time exception because usually collisions aren't paid out for, but in this case it was. Leon Spacewalker was awarded $2.2 million and the independent researcher $1.2 million at the time, since they were paid out in the Matic tokens. And it was also discovered that outside attackers had also found and exploited this issue to steal about 801,000 tokens, or around $1.8 million or so. Um, Curious why they would only steal that much when they could have potentially stolen a lot more. I don't know if it was because they were trying to keep it under the radar.
I
Yeah,
feel
I don't
like
know. Kind of
that's
fun to speculate on, but
got to be a big reason for it, because like if you just like stole every Matic in the ecosystem, what's left? Like you've got all the money. Who's going to accept it when they know every bit of money's been stolen?
yeah, you kind of devalue your own like
Yeah.
stolen goods. So not very smart.
That's the challenge with a lot of these sorts of issues is they can steal a lot, but as soon as they do make some sort of big transfer like that, they've devalued the entire ecosystem. Like they've made their own stolen goods like valueless.
It's very destructive to the
Yeah.
ecosystem for sure. Yeah. Um, but yeah, very serious and very costly issue overall. And like I said, like I just don't really know how they could have written this contract code and just been okay with it and deployed it. This seems like the kind of code that you would want to audit and test thoroughly when you're dealing with transactions like this. Um,
I mean, the idea that if transfer was supposed to have a the balance check on it, that is like if I were reviewing this code, that is one of the first sorts of things that you would look for in like a bank transfer. Can you transfer more money out of somebody's account than they have? Like that is the standard test case. That's why I'm unsure if that's actually the root of the problem here. Um because it feels too obvious to me. Oh, again, I don't want to say like, oh, it's just entirely obvious and all that, because this isn't an area that I've specialized in or really put a lot of time in learning. So take all of my thoughts with a grain of salt. It's just my thoughts reading this like a normal application. And reading it like a normal application, this is like if that were the issue, it's like the first thing that somebody would look at. I guess I can just leave it at that.
so something interesting that I was thinking about while you were talking that I don't know how much we can go into a discussion on it because, like you, I'm not really too ingrained in the crypto ecosystem, uh, or like smart contracts in general. But one thing to keep in mind with smart contracts, especially like Ethereum based ones, is one of the primary mechanisms in Ethereum is this concept of gas, and it costs gas to execute transactions. So the more complex your smart contract is, and the more instructions it has, the more it's going to cost to execute. So it kind of incentivizes this thing where you have to make or have to write the most efficient contracts as possible, to avoid paying more money to execute them. And I almost do wonder if that is one of the causes of these types of bugs, is the fact that you're incentivized to try to reduce the amount of code that you have by as much as possible. And if that means eliminating some checks that would otherwise keep you safe, then like maybe there's some penny pinching going on there. I don't know. I'm full speculating at
That's a
this
fair
point.
point, though. Good consideration.
Yeah, but it does make me think like smart contracts are almost backwards in the way that they incentivize you to write code. It's kind of, it doesn't really make a lot of sense from a security angle. So yeah, but overall, like I said, a costly vulnerability to have. So a very high impact one. So we were definitely going to cover it on the show. All right, so we'll move into some of our research for the episode, and then we'll move into shoutouts and wrapping up. So for research, we have a topic from PT Swarm Security, specifically a researcher named Igor Sakovsky, who was looking into fuzzing for cross-site scripting vulnerabilities in HTML parsers. Z, you were the one who brought this research up and found it interesting, so I'll let you take this one away.
Yeah, and with this one, what they were looking for was specifically title here, fuzzing for XSS via nested parsers condition. The idea being occasionally in applications, you're going to have more than one parser run against code. So say you might have something that parses the video and some other parser, like they use, like they look at BB code sort of things, markdown, restructured text, that sort of parser running over. Might, run a pass looking for video and then run a pass looking for emails or links to turn into clickable links. Might do something like that. So looking for issues where you have nested things there. But what I found a bit more interest here, and I'll also state they found a bunch of bugs here from like various BB or bulletin boards, PM Wiki, MyBB, vBulletin. Plenty of issues involving this sort of thing. But it was the idea of fuzzing that caught my eye, because fuzzing on the web is kind of a weird space. When we talk about fuzzing most of the time on the podcast, it's during our binary episodes where we can talk about fuzzing for crashes effectively. You fuzz, you give it all this random input. Eventually, you get a crash, and it's like, okay, there's probably a bug here because we got a crash. On the web, you don't have a crash to indicate a bug happened. It's a lot harder to detect something when you run all these automated cases. And they don't go into too much detail here. What they ended up doing, they had two ways of detecting it. One was just looking at the results and seeing, like, what you expect, the video, and then just the HTML code is treated as whatever. Like, it's encoded and it's just visible plainly there. The other way they detected was just looking for a opening HTML tag or opening angle bracket in the inside of another tag, indicating, hey, something went wrong. I think that's a good solution. Like, I like that one, at least for this sort of fuzzing. I just thought it was interesting, this idea of doing any sort of fuzzing on the web and trying to automate that whole process. Because the other option is you use something like, what is it, FLUF, or however you say the name. Basically, you just run your test cases and then you go look manually. It's really hard to do like a proper fuzzing campaign on the web. You also don't have things like code coverage, or often in many setups you won't. I guess you could have code coverage. So I found it a little bit interesting on that side of things. It's just, how do you approach this sort of fuzzing? I would have liked it if they also include a little bit on how they generated their test cases. They talk about like why they had certain test cases, but they just have their building logic rather than actually providing the, like, what they provide here is, here's the fuzzless fragment that just includes a bunch of these test cases, and I'm assuming they created these automatically somehow. Um, Actually, I guess they do. Yeah, I mean, it's.
Could be like
I would
seed
have.
test cases that they like mutated, but yeah, I can't really find where they talk about that, if they do.
Yeah, like they talk about the
Fortunately,
actual test cases themselves, but I feel like they would have got that list either somebody else generated, fine. But that's another aspect of fuzzing, is coming up with your test cases. That I think, even on even in this case, like, it would be an interesting project to look into, how do you generate these sorts of test cases. How do you probably want to go with like a grammar of sorts? That way it can like generate somewhat valid and invalid things.
the one that makes the most sense to me is just taking initial test cases of what they think would be useful from public examples or previous vulnerabilities or whatever, and then just doing mutation on top of that. They could be doing like
But
grammar-based generation, which would be impressive too. But
what type mutations here? So like the key thing here, because they're looking for these nested ones. So like they have the URL example, and then inside the URL they include the font. So you need to have some that knows like, okay, the URL can be written in this way, where it's like start end URL tags, and you can inject something else into the middle of it. Like that's where I'm thinking the grammar idea versus just random, because random I don't think would be too effective here either. Just random mutations, because I mean it's not random. You need the proper structure of these tags in there in order for the parsers to match them. Either way, that was some that I felt like they didn't quite have enough information about that I would have liked more information on. But oh no, on a whole, I like the idea of the web fuzzing, and I'm always kind of keep my eye out for some of those posts. This one covers a very basic level, but fuzzing on the web is still, in a sense, in its infancy. Like there aren't really strong, fully automated fuzzing setups that I
it's a
know of.
harder area to apply it to. Yeah.
Yeah, because I mean, you're like I mentioned before, you don't just get a crash to indicate there's a bug. You can't just write a sanitizer to cause a crash and indicate like, hey, there's a bug. That is something that I think would be somewhat more effective for, especially with XSS, is running some like basically modifying your browser so that like certain JavaScript functions or JavaScript errors will trigger an indication that something's gone wrong. Like I could imagine kind of building a sanitizer into your browser, kind of, and doing
That'd be
something
very
like
interesting.
that. Like it wouldn't be a sanitizer in the traditional sense. Like I don't want to crash the browser when there's a bug, but having another way of indicating that the bug happened. I feel like that's probably one route that's worth exploring. But yeah, I mean, it was an interesting post, and I just thought it would be a launching point to talking a little bit about the fuzzing aspect. They found a bunch of issues doing it, and that is a clear area. Like if you're testing things, uh, multiple parsers are just all the translations that happen when you can embed things. You're bound to kind of start finding issues there.
All right, so we have a few shoutouts before we end off the show. The first of which is a post by Houston that details various different cache poisoning attacks and patterns that they used on some well-known sites. In total, I think there's 9 different techniques detailed here that impact over 70 different targets. Um, Lots of various different techniques here, although all kind of based on the same thing since it's cache poisoning. Having a desync in what's being stored versus the cache keys. Um, a few interesting ones there being like one in Apache traffic server, which had like some issues with URL fragments. There was also GitHub and GitLab made an appearance in there with how they parsed headers mostly, I believe. Like they brute force unkeyed headers to try to find some cache poisoning issues. But yeah, there's a lot of different attacks here that were used. And that's kind of the point of the post is cache poisoning at scale. So obviously this is used to hit a lot of targets and whatnot. A little bit too much, I think, to cover as like a full topic. But still an interesting read, especially if you're into cache poisoning and that those kinds of attacks. Um, did want to give it a shout out for anyone interested in that.
Yeah, I mean it's a common enough attack surface. Like it's really exploded since it really got pointed out. Well, I think it was known about for quite a while, but the last few years have definitely kind of seen it explode quite a bit. Decent write up on it. I at least just want to shout it out here. I think some weeks we might have even covered it if it was a little bit slower, but um yeah, I mean they found quite a few issues and probably got a pretty decent bounty out of it. They only include numbers for a few of the bounties though. So we don't have a full number, but probably got a good amount when they're hitting like 70 plus targets, or successfully hitting 70 plus targets.
Yeah, and even the numbers that were posted for some of the disclosed sites like GitHub and GitLab, they were a couple $1,000s for those issues. So they at least made that much. For our last shout out here, we have a post from David who we've covered before. Z, this is your shout out, so I'll let you talk about it, and then we'll wrap it up.
Yeah, not much to actually say about this one. We covered this vulnerability. What this is a write-up now. So a while back we covered a Google Cloud vulnerability, SSRF, where they had patched it and then they bypassed the patch and they patched it again and bypassed the patch again. Had that back and forth a little bit. This is a little bit more of the story on what was going on there and more information about what they were searching for and how they came about. Because we talked about the actual bug report itself, whereas this is more of a blog post and write up for it. So yeah, I just want to shout out. It's there if you want a little bit more information about that bug. I should have looked up what episode we covered it on, but unfortunately, I don't have that information. But Google Cloud SSRF, if that rings a bell, you might remember the episode.
I will try to put it in the description. I don't know if we'll be able to find it like live during the episode, but we'll try to put it in the description of the video for anyone who's interested. But yeah, so that's where we'll wrap up the bounty episode for today.
I
Thank you to everyone who
actually,
tuned in.
I guess I can say it was on our November 30th episode.
Okay,
So
so a
that,
fairly recent one.
yeah, yeah.
Okay,
The
cool.
old title there was URL whitelist bypass.
Okay.
That's the one where I used the /@ to get around. Anyway, we covered it. It's there from the 30th, November 30th. So if you want to get all the details on it, but there's more information available. So figure out at least let people know about that.
Cool. All right, so yeah, once again, thank you to everyone who tuned in. The VOD will be available on other platforms like YouTube tomorrow. You can also find previous episodes up on Spotify, Apple Podcasts, and Anchor. If you want to join our Discord or follow us on Twitter for when we go live, links for those are down below or in the chat. And yeah, tomorrow we'll be back on Twitch with our binary episode of the week at 7 p.m. Eastern, 4 p.m. Pacific. And until then, take care.